Question 7. Reflect the given polygon. It's a simple little triangle. Reflect the given polygon across the y-axis and then rotate the resulting, the new polygon that you just got, 90 degrees clockwise around the origin. Of course, the origin is just a fancy name for that point. X is 0, y is 0. So let's begin with the reflection. So the reflection across the y-axis. So we can see our y-axis, and we're going to reflect across that. So pretty straightforward to do reflections in general, especially across the x-axis and the y-axis. Remember, anytime we reflect across the line, all the resulting points are the same distance away from the original. So if I was to start reflecting, this point right here is going to be 1, 2, 3 away. So it's going to go 1, 2, 3. It's going to go right to here. It's beautiful. That's the resulting point. This point right here, you can see this point is 1, 2 away from my line of reflection. So it's going to be 1, 2 away on the other side of it. And then the final point right here, I can see that it's -5. It's 5 away. So I'm going to 1, 2, 3. So it's going to go all the way to x is 5. And y is going to stay the same at 2. So I can see my reflection. Let me go ahead and draw the lines that connect those dots. I thought I paused that, but I recorded the whole thing. Okay, so the next thing we're going to do is go ahead and do now our rotation around the origin. So you can see our rotation, our origin is this point, and we're going to rotate around this point entirely. And kind of a difficult thing to think about for a while, but it helps me just to remind myself of what I'm going to be doing, to think about, oh, I messed up my eraser. It helps me to think about what I'm doing is if I think about this little line segment right here, okay, this little line segment. So if I rotate 90 degrees clockwise with the clock, right? If I think about that little line segment, I'm going to still, this line segment's still going to be at the origin, but it's going to be I'm going to have a slope that's opposite reciprocal of that slope. It's going to go down into quadrant 4, right? But it's going to have an opposite reciprocal slope. Right now, that's up 1 over 2. So that's a slope of 1/2. I'm going to need a slope of -2. So I can go down 2 and over 1. Now, this point right here, as soon as I draw it, I'm like, oh yeah, that kind of makes sense, right? I can see that if I was to connect this point back to that origin, right? This is clearly the 90 degrees, right? So this is one of the first things we looked at about how do we know that lines that are perpendicular to each other have opposite reciprocal slopes. Well, we can see that here. But I think more importantly is this gives me an opportunity to kind of think about what's happening. So I know that the green dot's going to the right spot, but what's happening? So what's happening is this original point, right? This original x comma y point was at x was 2 comma y was 1. So I can see where it was. Now I want to note where it goes. It goes to a spot where x is 1 and y is -2. Now, this is not a proof by any means, but I want you to observe what happened here. It appears that X and Y switched locations. In fact, it looks like what was Y, right, became X. So what I'm saying is that my former Y value, right, the former Y value went into the spot where X was. And it also looks like the X value, right, it was 2, it went to the spot where Y was, but also I took the opposite of it. So I'm going to write the opposite of it. So this becomes a roadmap for me to think about all of these spots, right? How do I think about all of them? I'm going to think about all of them exactly like this. I'm going to think about each xy is going to go to the y and x are going to switch places, and because I'm going clockwise, when I land y into the x spot, I'm going to take the opposite sign. So by taking a moment and thinking about exactly what's happening there, it's a lot easier for me to graph the remaining points. So if I think about this point that I've marked in yellow, this point had an x value of 5 and it had a y value of 2. So they're going to switch places, and what was x, positive 5, is going to become negative 5 for the y. So this is going to go to the spot x is 2, y is negative 5. There it is. I'll put the yellow dot right there. Wow, that was nice. And in fact, if I drew those lines back in with the origin, I would see the same right angle there. And just visually, it certainly appears as though origin to that dot and then dot origin to the new dot is making a right angle. Again, not an argument, but look at the slopes. Look at the slopes. And then for the orange dot, last point up here, this was at x was 3 and y was at 6. So again, they're going to flip places. So now I'm going to go 6 and then negative 3. So I'm going to go over 6 and then down 3. And this right here is the spot. Looks like class is starting soon, so I will not use the ruler. I'll just go ahead and sketch. I'll just sketch. So this is my resulting triangle after I rotate 90 degrees around the origin.